Let's talk a little bit about geometry. Suppose we have a line and then there is a point on the line. So if you draw a circle, you can see that this angle right here is pi and this angle right here is also pi. And I would like to see and explore how to divide this pi angle into 2 equal halves, 3 equal parts, 4 equal parts, 5 equal parts and 6 equal parts. So you might have heard that bisecting in any angle is very simple. We will talk about that also in this video. Trisecting any general angle is not possible. But this I'm talking about this special angle pi, so it might be possible. How about 4? So you bisect 2 times, you get 4 parts. 5. This is going to be very interesting. This video is especially about this cutting pi into 5 equal parts, and 6 will be easy because you have already done 3 and 2. So let's do a quick recap of bisecting, trisecting, and 2, 3, 4 and 6 parts. We will do a quick recap. So let's start with how to bisect. So you can take these point, equidistant point from this point where your 180 degree angle is. So here is your 180 degree angle or pi. So from here you get these 2 equidistant points, and from here you can draw 2 arbitrary circles big enough so that they can intersect. And if they intersect at these 2 points, these 2 points are definitely going to be the perpendicular bisector. You can understand it by symmetry. When I say symmetry, you can construct some triangles and prove that this is exactly what we are getting an intuition of. So you can construct these 2 triangles. You see, this and this. So this is the radius of the smallest circle R, the smallest central circle. This is also R. This is the radius of the bigger circle, capital R. We can say it. This is also the radius of the bigger circle, capital R, and this length is common. So these 2 triangles are congruent. That's why these 2 sides are also same, and these 2 angles have also been bisected. So that way, by using congruent triangles and making triangles in such a way that they are the radius of one of the circles, you can prove that this is exactly the same, what we are getting an intuition of by symmetry. Okay, so now these 2 circles, you see, these 2 circles, if we make them small, if they make them quite small like this, they won't intersect and we wouldn't get any special point. So you will have to make them big enough. But suppose you make them smaller and smaller in such a way that they do not intersect but they touch at the center. In this case, you will have all these 3 circles of same radius, and using these points here, you can construct this angle, these triangles you can see. So you can construct this triangle right here. You see what is special about this triangle is that this is the radius of one of these circles. I think this is the radius of both of these circles, this one and this one. So this is R. This is the radius of the central circle. This is R. This is the radius of the rightwards circle. So this is also R. So you've got an equilateral triangle. So you've got a pi by 3 angle here because the sum of the angles of triangle is pi. So all these 3 angles should be pi by 3. So this angle right here is also pi by 3, and we have divided pi into 3 equal parts. You just have to extend this construction on the other side also. So we get pi by 3, pi by 3, pi by 3. So now if we want to divide pi into 4 equal parts, what we can do is we can use this general algorithm of bisecting any angle. So you can take these 2 points at an angle 90 degree at a same distance. This is R, this is R, and then you can construct 2 arbitrary big circles. Should construct 2 arbitrarily big circles. So this point right here is the point of intersection, which and you might feel like if you join these 2 points, you would be able to see that you are bisecting an angle. But to prove it, you can construct these triangles and prove that they are congruent. So this length right here is small r, this length right here is also small r, this length here is the radius of the bigger circle, capital R, this is also capital R, this is common, and that's why you have bisected these this angle. Okay, so 45 degrees or pi by 4 we can construct like this. Now I won't go into 5 right here. I will first show you how to cut into 6 equal parts, cut pi into 6 equal parts, and then we will go into 5. So that's easy, right? Because you have got pi by 3, you just have to bisect pi by 3 and you will get pi by 6. So again the same algorithm, you mark these 2 points and you can take 2 arbitrarily big enough circle and you can get this point of intersection right here and you can join them. You can complete the proof yourselves, you can do it the same thing on this side and you can get pi by 6. So you've got pi by 6, you've got pi by 6, another pi by 6, you can complete it like this line here, 90 degrees will be like 3 times 30 degrees. So another pi by 6 is here, pi by 6 is here, pi by 6 is here, and pi by 6 is here. So till now we have seen how to divide your pi into 2, 3, 4 and 6 equal parts. But now comes the interesting part, how to divide pi into 5 equal parts. So dividing pi into 5 equal parts has a very important application. It will help you to construct a regular pentagon. So if you don't want to see this method, I really appreciate it, because you know the problem now. You know I have introduced you with the problem. You can go ahead and take your time and give it some time, think about it, come up with your own method. You will feel very happy about it. And if you want to see my method, I will show you that also, but I recommend first try it on your own. So what I have done here is I take a circle like this, and then I take the perpendicular bisector, and then I take these midpoints of the radius here, and from here I draw these 2 smaller circles of radius r by 2. Okay, and then I go on constructing this kind of construction nearby also. So you see this point here is just where this bigger circle, the black circle, is cutting this line. So from here I can draw the same circle of same radius. So these black circles are of same radius, and then I will draw blue circles like before. So you see, like, you can prove that these circles are touching here, these circles are touching here, these are touching here, these are touching here. So a lot of point of contacts of these circles you can see here. It's a beautiful pattern will emerge out. On this side also you can do this construction and you get this beautiful pattern. So the blue circles are not very important. I have drawn it to draw some very interesting kind of circles, which I will show you how I will draw here. I will take this line. So this is the radius of the black circle r, this is the radius, half of the radius of the black circle. So this length, you can think about how much this length is. But what I'm doing is like connecting the center of the black circle to not to its own half circles, to the adjacent half circles, Here also you can connect these kind of lines. And on this line, on these lines, like on one of these lines you see here, you follow a blue circle and mark this point of intersection. And from here you take this as a radius, okay, from the center of the black circle, and this point as the radius, you draw this very beautiful circle. By symmetry, you will see that this circle will also touch this circle here and this circle here. Okay, we'll do same kind of construction on the other side, like this, and then like this. So I've got my red circles. My red circles will have some very interesting radius, which we will figure out. But just take a look at this beautiful pattern. Okay, so when you have drawn this pattern, you might not be able to see it like very simply, but I will tell you that in this pattern I have the points which have already divided pi into 5 equal parts. Where are these points? These green points. These are the point of intersection of red and black circles. Red and black circles. And you join these lines, this one, this one, this one, and this one, and you see that you have divided pi into 1, 2, 3, 4, 5 parts. We just have to prove it that they are all the same, that these angles are all pi by 5 exactly. This is not an approximation. I don't like approximations, of course, so nobody should, in terms of like when you're doing geometry at least. So how am I going to prove it? So first let's think about the radius of the inner red circle. So this distance is the radius of the black circles. This is r. This distance is the radius of the blue circle, which is r by 2. Let's bring this line using which we constructed the red circles. So this line, what is the length of this line? So you can use Pythagoras theorem. This is r by 2, this is r, right? And then r root 5 by 2. And then from here you bring in this point, this point right here. You see this is r by 2 and this is the radius of the larger red circle. So r by 2 plus r is going to be r root 5 by 2. So your r will be r by 2 root 5 minus 1. So this way you can figure out the radius of the inner red circle. Okay, once you have figured that out, what is the next step is like I will draw these lines. These two lines, as you can see, they are of the same length. This length I can call capital R, so they are of capital R length, and this length here is also capital R. If we prove it, then I can prove it to you that the angle which we have made here, or maybe these angles which we made before, they are pi by 5. So this angle will turn out to be 2 times pi by 5, because you see when you draw these lines which I showed you before, you will get 2 times this pi by 5. But I'll show you the complete proof. So let's first focus on proving that this length is also r root 5 minus 1 by 2 or capital R. How can we do that? So we can use Pythagoras theorem. We can construct these lines here, pink line, blue line and yellow line. And let's say that this distance is x, the yellow line is x, of x distance. The pink line, you can say that this is r minus x, because this whole length is r. So pink line is r minus x, and the length of the blue line, so this is going to be, let's say that this is y. So we have two variables to figure out. So if we can figure out this x distance here, by symmetry you can see if we draw another line here, this distance is also going to be x. So the length of this red line which we are thinking about is going to be r minus 2x. So the idea is to first figure out what x and y is, which you can do very simply. First you can take this triangle, this one, and apply Pythagoras theorem. So you will get r minus x, this is r minus x squared, this is y squared, and this is the radius of the black circle, this length AB, let's call it AB and C. So the hypotenuse, you can see, is the radius of the black circle. And from here you get this equation. You can simplify this equation a little bit. R squared will get cancelled out and you will get this equation number 1. Let's say that this is equation number 1. Then you can take another triangle, this smaller triangle here. So you have x here, x squared and plus y squared. This is the radius of the red circle, which is capital R, or which is this value here. So you make this another equation, and you see it's very easy to solve them. You can subtract 2 minus 1, x squared, y squared will get cancelled out. This minus 2rx will become plus 2rx is equal to r squared by this, and then very simply you see that this is your x. And what we have to calculate? We have to calculate this yellow line here also again, and then this length is x also, right? And then we subtract r, this length is going to be r minus 2x. So r minus 2x, just do a quick calculation, and believe it or not, it will turn out to be same as the radius of the red circle, or capital R. So now we have proved that this length, the length of this line is same as these two. So the length of these red lines are same. Okay. So now comes the other part, proving that we have bisected the pi into 5 equal parts using this. So construct this line here. We see that this angle is theta. Let's say that this angle is theta. Then this angle is also going to be theta, because these two distances are equal. We have already proved. So that is an this ABC is an isosceles triangle basically. So that is theta. So now this line right here is parallel to the x-axis, right? All these points you are going to get on the same height. This you can also prove by symmetry, by using some very simple congruent triangles. So I leave it to you. If you want that rigorous proof, you can figure it out yourself. It's not a big deal. So these two lines are parallel. So then I have, if this angle is theta, this angle is also going to be theta. This is what we call alternate angles. So that is also theta. Okay. Now this angle is going to be 2 theta. Why? Because this angle, you see that this angle right here, this point right here, and this part, this angle right here, these two are going to be same by symmetry, because whatever circles you are cutting here, you will have here in between the perpendicular bisector is going to be the line of symmetry of this whole construction everywhere, isn't it? This, like here, you have these two lines, and then from here, if you draw this line, it will go through these point of contact of these blue circles. It will also go through point of contact of these red circles, and the whole situation will be symmetric about these 2 points. So using that, if this angle is 2 theta, this angle is also 2 theta, and then that angle is also 2 theta, because this is the radius of a black circle. This red line is the radius of this black circle. This line is also the radius of the same black circle. So let's call this ABC, and now this ABC is isosceles, so angle B and C here should be equal. Okay, so now let's look at this triangle ABC. I keep changing the names of my points. So ABC, so theta plus 2 theta plus 2 theta is going to be 180 degrees, right? Because the sum of angles of a triangle is 180 degrees. So using from here, you get 5 theta is equal to 180 degrees, and then your theta will turn out to be 36 degrees. So this is the proof why we have been able to construct these 36 degrees angle here. The rest of it, I leave it for you to fill in the gaps and rigorously prove that these thetas are 36 degrees. Okay, I will do a quick recap what I have done. So I make a point and a circle. So I focus on this 180 degrees. I extend my construction. I make these smaller circles, half circles, and then I extend the construction on the other side, on both the side, make smaller circles and the bigger circle, and then I connect this line. This is here. This is the most important part of this construction. This line here, okay, and this radius is going to be r root 5 by 2, but I would like to subtract this r by 2 from that, and then construct a red circle like this. And these red circles you can go on constructing on both of the side, on all the sides, and then you get this beautiful figure. And then the point of intersections of black and the red circles, these points will help you to draw these lines, which will give you pi by 5. Great. So Now I am going to talk about how to do construction of a regular pentagon. So regular pentagon, like we all know, if it's a regular pentagon, all the angles will be same, right? And let's say that these angles are theta. So 5 theta will be equal to, so you can construct like 3 triangles inside a regular pentagon, and all these angles will sum up to 3 times 180 degrees. So your theta which you want to construct at one of the vertices of the regular pentagon is 3 into 180 degrees by 5. So 36 degrees into 3, so that turns out to be 108 degrees. So you can see it like you can construct 90 degrees plus 18 degrees. You can do that, or you can construct 72 degrees plus 36 degrees. So this is basically 3 times 36 degrees, 3 times pi by 5, right? Let me see it again, once again. So I see, yeah, 5 theta is equal to 3 times pi. So the theta is going to be 3 times pi by 5. So we have constructed pi by 5. In that same construction, we have seen how we can take 2 pi by 5 and 3 pi by 5. So we are going to use that construction. We suppose this is the edge of the pentagon which you want to make. So this is the edge, and I will construct a regular pentagon on the upward part like this, not downward here. Okay, so this is the edge. This at this point you mark these 2 points, and then you extend this line right here, and then this is the same edge length, let's call this A, and then you construct this circle A, and then from here you do construct, you see what we are doing here, we're constructing those smaller circles, and then we are taking this line, and then we are constructing the red circle. Okay, the red circle and this point right here. So you should have had one more green point right here, and then there would have been another red circle going from here, and then one more green point here. So this would have been pi by 5, this would have been pi by 5, and this would have been pi by 5. So if you connect this green point, this special green point which we have taken, so and extend it to the same length A as before, so then you get one of the parts of the regular pentagon. And once you have drawn these 2 edges, now it's very simple. I think you can figure it out. The regular pentagon is going to have a center, a circle circumscribing that regular pentagon, and that center you can figure it out by bisecting these chords, and this is the center of that circle. This is also a very common construction, and I hope my viewers know it. So you have got this circle circumscribing our regular pentagon, and from here you can take this circle and you can just mark these edges. What is this circle? This has a radius A basically, and you put it here on here, so you get this point. You put the same circle at this center, this point, you get another point, and just to prove it, you will put it here and you will get a point, this point, the first point before, like so. Yeah, just join them. You've got your beautiful regular pentagon. Notice that this is not an approximate construction, this is exact. There are many approximate constructions on YouTube, but if you see those construction and you find error in them, that is what I think is actually the goal of mathematics. Like, you don't believe in my words, you check it for yourself. So I've given you a proof, you can think about the proof also. If you find any error, I think you won't, because I spent a lot of time in figuring out this method. So don't accept my method, develop your own. And if you are interested, then go into like dividing pi into 7 equal parts. I have been thinking about it and I don't know how to do it. By the way, pentagon, because Euclid has given his own construction of regular pentagon in his very famous book Elements, and some other people have also given their methods, so I was inspired by them to think of my own method. I didn't look into their methods, to be very frank, and I did this construction on my own first, and then now I can go and look into their constructions, and I will see like how they can make it more simpler or things like that. So keep exploring, keep having fun with mathematics. That's all for this video. Thank you.